Hi everyone, welcome back to my channel. So in this video, I am discussing SICXE machine generate object program. So this is the example which I am discussing in this video. So in this example, label, opcode, operand is given and also the mnemonic code for the opcode is also given. We need to calculate the location counter, object code and also write the object program. In SICXC machine architecture, there are 4 instruction formats. Type 1 is of 1 byte, type 2 is of 2 byte, type 3 is of 3 byte, and type 4 is of 4 byte. Based on those instruction format, we add location counter and write the value for the location counter. So initially, here we are having the starting address 0. So we write the initial address of location counter to be 0. And the next, you can see the next operand, it is X, that is index register, which means it is of format 2. So we are adding 2 to the location counter. So it becomes 002. Next, we are having hash 0. Hash is nothing but immediate, which means that it is of format 3. So we are adding 3 to the location counter. Now we are having hash total, but in the opcode we are having plus. So plus indicates that it is format 4. So we need to add 4 to the location counter. Since we are having base, we are not writing any location counter value to the base. So we are moving to the next instruction and writing there. So we are adding 4 to the 5. So it becomes 009. Okay. So now this instruction is also format 3. So we are adding 3 to the 3 to the location counter. So it becomes 00C. So rest all is 3. So it becomes 00F, F plus 3, 0012, plus 3, 0015, plus 3, 0018. Now, whenever we have RSEW, we need to multiply the operand with the format. So it is 1 into 3. So this value we are going to add to the location counter. So it is 0018 plus 3, which becomes 001B. Similarly, for the operand 2000, we are multiplying with the format 3 and it becomes 6000. 6000 hexadecimal equivalent is 1770. So 1770 plus 001B gives us 178B. Okay, and similarly to the next instruction, we are multiplying with the format 3 and we are adding it to the location counter and we are getting 178E. So this is how we calculate location counter. So now let us write the object code. To write the object code, we need to know the format of the instruction format. So initially, now we are having index register X for this instruction, which is of format 2. So we can directly write the object code here. So to write the object code, first we need to see the opcode. So the mnemonic code for the opcode clear is B4. So this becomes B4 and the value of X is 1 and then we write 0. So this is the object code for this instruction. So let us move to the next instruction. This instruction is format 3. So format 3, so this is the format for format 3, where we write 6-bit opcode and 6 addressing mode, where each one having 1 bit, and 12-bit address for format 3 and 20-bit address for format 4, and this is the displacement address. Okay, so whatever the displacement we calculate, we are writing this in this bit format, bit address. So let us write okay, addressing mode. So N is the indirect addressing mode, I is the immediate addressing mode, X is the index addressing mode, B is the base relative addressing mode, P is the program counter addressing mode, and E is 0 for format 3 and E is 1 for format 4. So now let us write the opcode for the instruction. So we are having LDA. What is the LDA is 68. So let us fill, sorry, LDA is 00. So it is 000. So we need to fill the opcode in 6 bits. So 0000. Okay. Now it is indexed. Sorry, it is immediate. Hash 0 is there. So it is immediate. That means I is set to 1 and N is 0. So it is not indexed. So it is 0. Okay. So whenever we have hash, that is whenever the instruction is immediate, then we then the base relative addressing mode and program count addressing mode is 0. Okay. And since it is a format 3, it is E is set to 0. And we don't have value, we don't, B and P both are set to 0. That's why we don't calculate displacement. Now let us write the object code. So this will be 0, 4-bit, 0, and the next 4-bit is 1, and rest all is 0, 0, 0, 0, and 0. Okay. So next instruction. So in the next instruction, we are having plus. It's of format 4. That means the displacement is in 20-bit address. And LDB, the opcode for LDB is 68. So let us write 6801110 is 6 and 8. So we write 8 in, when we write 8 in 4-bit format, it is 1000. So here we need to ignore the last 2 bit. We need to consider only the first 2 bit. So we are considering 1, 0. So we are writing only 1, 0. So it is immediate. So I is set to 0 and N is 0. Sorry, I is set to 1 and N is 0. And X is 0. Since it is immediate, we have P and B value to be 0, and it is format 4, E is 1. And when we, what is the displacement we're writing? So whatever total, in the operand we are having total, just go to the target address of total in the location counter. It is 178B. Yeah. So we are writing this in the object code. So it is 6910178B. 698 plus 1 9 and 10178B. In the next instruction, it is base. So no need to write the object code for base. We're moving to the next instruction, that is add. In the what is the opcode for add? It is 18. So we'll write 18 here. 0001 and 8. 8 is 10. Okay. Since it is, you can see here, it is neither neither indirect nor immediate. So in that case, both N and I are set to 1. Okay. And here it is index. X is also there. So it is index. That means X is also set to 1. Now, P, it is of format 3. So E is also, he is 0. Okay. E is 0. And we need to calculate the displacement. So to calculate displacement, go to the location counter of table. The location of table is 001B. 001B minus the next instruction. Next instruction is 00C. 000C. That is equal to F. So this F lies in the range of -2048 to 2047. So that's why it is program counter, or let's say addressing mode. So that's why P is set to 1 and B is 0. So the object code for this is 1, B, A, 0, 0, F. Next instruction, TIX, the opcode is 2C. So 0, 0, 1, 0 is 2 and C is 1, 1. Okay. Now, it is neither indirect nor immediate. That's why both are set to 1, 1. It is not index. So it is set to 0. Okay. We need to decide whether it is B or P. It is in format 3. That's why E is 0. So the count. So count location counter is 0, 0, 1, 8. 0, 0, 1, 8 minus the next instruction, that is 0, 0, F. 0, 0, 0, F. And this is equal to 9. Okay. So this tells it is PC addressing mode. That's why P is set to 1 and B is 0. So if we write the object code for this, it is 2. Can see this is F, F. Then again it is 2 and 0, 0, 9. Next is JLT. JLT opcode is 3 and 8. So it is 0, 0, 1, 1 is 3, 1, 0 is 8. So both N and I are set to 1 since so it's neither indirect nor immediate. That's why both are set to 1. And there is no index register. That's why it is 0. Now it E is 0 because it is format register 3. Sorry, the format is 3. And with the displacement. Now loop is 0, 0, 9. So 0, 0, 0, 9 minus the next instruction. Next instruction is 0, 0, 1, 2. And this gives minus 9. So minus 9 in hexadecimal is FF7. FF7. And so this is also PC. So P is set to 1 and B is 0. So if we write the object code for this, it is 3, B, 2, F, F, and 7. Okay. Next is total STA. STA opcode is 0C. So it is 0, 0, 0, 0 and C is 1, 1. So both N and I are set to 1 and X is 0 and E is 0 because it is format 3. And to find the displacement, the total is 178 B minus the next instruction, that is 0, 0, 1, 5. So this gives 1776. 1776. So this is the range. This is in the range of base relative addressing mode. So that's why it becomes 178 B minus 0015 plus 1776, that is 178 B, which is equal to 0. So that now the displacement is 0, base is 1 and P is 0. So if we write the object code for this, it is it is 0 F 4 0 0 0. Now R sub. We don't have any operands, so R sub opcode is 4C. So we'll write 4 0 1 0 0 0 is 4 and C is 1 1. It is neither indirect nor immediate. That's why both are set to 1 1. It is not index, so it is 0. But both B and P are 0. and E is also 0. Displacement is also 0. So we get 4 F 0 0, where I'm writing 4 F 0 0 0. So this is the object code for the program. So now let us write the object program. So this is the object program for the given example program that we solved now. So first row is the heading, where H, the first column is the H, capital H, which represent the heading, and the next 6 column is for the name of the program. So here the name is sum. Here the name is sum. So that's why here SUM is written, and the next 3 columns are blank. Next, we need to write the next 6 column is the starting address, and then next 4 columns are the length of the program, object program. So how do we calculate the object program length? It is the end address minus the initial address. That gives the length of the program. So if this is the end and this is the starting, so when we minus it, we get 178E. Next row is text. So capital T, the first column is capital T, which represents the text, and the next 6 column is the starting address, and I'll tell what is 18 after telling about the next columns. So here, this is the object code. So whatever the object code obtained in the object program, so we are writing it here. And totally the text column should have 69 columns. Text row should have 69 columns, where the first 9 columns are filled for the T starting address and the 2 bits, and the rest 60 columns are filled with the object code. So if the object code exceed the 69 columns, then we need to move to the next line. And we need to follow the same procedure as we followed for the first line of the text. So how we got this is, we need to count the object code column from where we started writing the object code till the end. So from here to here, if we count the object code columns, we will be getting some 48. Okay, so where in this 48 columns, 2 column is the 1 byte. Okay, so that's why we divided by 2, which gives 24. Okay, now this 24, when you convert it to hexadecimal, it is 18. So that's why we wrote 18 here. So next is end. E, capital E represent the end, and we write after end, we write the starting address, 6 column starting address. So this is the object program for the given SICXC machine generate program. Okay. Thank you.